So children, coming to question number 30, it was given that a spherical ball has been dropped in a glycerin and he has mentioned viscosity. So by looking at this, you have to get an idea. Viscosity. So this is from mechanical properties of fluids. Mechanical properties of fluids chapter. Okay. And this concept belongs to viscosity. So how to? So what is the formula? So look here, let me take a spherical ball. Let me take a spherical ball like this. Okay, mass m. So its downward force is mg. Clear? So where is upward force is buoyancy force. Now, when it attains constant velocity, so constant velocity, what does it mean? Since it is coming down with a constant velocity, so no doubt its acceleration is nothing but change in velocity, which is equal to 0. So that we have to know. So the equation for this, how to calculate this equation? So here downward force is mg, that is bigger. Mg is greater than buoyancy force. So what I could write is that bigger force minus smaller force is equal to net force. Okay. So mass m could be written as mass is equal to density into volume. So volume is, okay, 4/3 pi r cube for a spherical ball. 4/3 pi r cube. This is what? Whereas coming to buoyancy force. So force again, this is also m into g only. So what happens here is that we could also express in terms of this density into volume. This is mass into g, like this. The problem is that buoyancy force is for liquid. So this is density of liquid. And here, whatever the mass you are taking here is there, no? This is for body. So density of body, like this. Be careful. So for this, what I write is that density of body into 4/3 pi r cube into g minus, okay. So other one is that I have to express buoyancy force. So now I'll take in terms of density only, but that is density of liquid. Pi r cube into g. In both the cases, what we could take common is that 4/3 pi r cube into g can be taken common. So density of body minus density of liquid. So 4/3 pi is 22/7, isn't it? Now coming to the radius r, it was given as 1 mm. Given as 1 mm. So r is 1 mm. What does it mean? Millimeter. Milli in the sense 10 power minus 3. So here I could write it as 1 into 10 power minus 3 whole cube. Coming to the value of g, it was given as 9.8 into, okay. So what he has mentioned, density of body. So look at the question, density of body, ball of a density is 10.5 gram per cc. So the density of body is nothing but 10.5, whereas density of liquid, right, so it was given as 1.5 gram per centimeter cube. So with this data, we have to calculate the force. It is equal to, if you look carefully, gram per centimeter cube is there here. Okay. So one gram per centimeter cube can be written as 10 to the power of minus 3 kg by 10 to the power of minus 6 meter cube. So what you get here is that 10 to the power of plus 3 kg per meter cube. So this has to be multiplied by 10 to the power of plus 3. Now everything is in SI system. So by solving this, the answer we get here is that 3696 into 10 to the power of minus 7 Newton. Okay. So what was given here is that F is given as 3696 into 10 to the power of minus x Newton. So compare these two values, my dear. Compare these two values. So what you are going to get here is that in place of 10 power minus 7, you have 10 power minus x. So therefore x is equal to 7. So the answer for this question is that the value of x is 7. Okay. So with this we have done our last question, that is 30th question. So our evening session paper has been done. I hope you understood this clearly. Thank you.